Greetings everyone and welcome back to the bench. Today on the bench is amplifier number 3 of 4. Working my way through reviewing these boards that people sent in to me. And well, it's taken me a while. I think this was sent in, it was back in spring, 3 or 4 months ago. I'm certain the person who sent this in is wondering why I haven't gotten to it, but I finally reviewing this. I got one more to review after this. I certainly do appreciate these being sent in, as it gives me some fodder for making a video, and people might be interested in seeing how these things work. Alright, let's get to it. It says ZK-502C 502C 50 watt by 50 watt. That's probably what that means. New. Glad that's new as opposed to being used. Made in China. Surprise, surprise. Well, let's crack this thing open here. So we get a board here. And there's no heat sink on it. There's a heat sink in the box there. And this is a another TPA3116 type board. Without the heat sink, you can see how small the actual IC is. So we have some nice screw terminals here, power jack. Let's say here 5 volts to 27 volts, though I wouldn't recommend going that high with it. Has a volume control with, looks like a power switch, or at least puts it in the standby. You see the little antenna looking thing here. This is Bluetooth capable, and the little mini stereo jack input. Nice size coils. Looks like these are part of the output filter caps, maybe. So yeah, let's see what else we get here in the package. And we get a little power connector here, a screwdriver, a knob for the volume control, and oh, that goes to the volume control, the washer and the nut there. And, oh, a little bitty heat sink. How many watts do they say this is? That little bitty heat sink? You gotta be kidding. No, it's not quite gonna do it. Even though it is Class D, it still has to dissipate quite a bit of heat. And it comes with a case, a little acrylic case here with all the hardware. I'll put this on at the end of the video because while I'm working on this, it'll be easier to access it during the test without the case installed. And the little manual. I won't get into this very much, so just pause if you want to read all this stuff. Parameters. 30 by 224, 50, is that what that says? 55 by 2 at 24 volts, 4 ohms. No, not with that little heat sink. Well, look at this. What they're saying here, 4 ohm, 6 or 8 to 12 volts, 8 ohms. They are kind of giving you a hint here, so I'm not sure why they included this if you can't run it at 4 ohms beyond 12 volts. It just tells you what comes with and questions and answers. Okay, I put the knob on, and we'll use their little connector here. It's this awful aluminum or a copper clad aluminum wire. you twist it and it just, yeah, it doesn't really want to stay twisted. Yeah, awful crap. But anyway, we'll use it. And the heatsink has thermal type adhesive. There's a little pad on there. You just remove the masking and attach it. But look how tiny that is. This is the same chip with the much larger heatsink. This is a mono amplifier. Parallel the two channels together. This is stereo configured, of course. But yeah, I mean, that's just so small. It'll get too hot if we push it too hard. We'll see how hot it gets. Okay, I have some speakers hooked up. Power's hooked up. And even with the volume control in off mode, it's drawing 30 or 40 milliamps. It's kind of jumping back and forth. This Bluetooth chip seems to have a little bit of warmth to it. So yeah, even if you think it's off, it's not. So if you use it with batteries, it'll drain the batteries down. So let me turn it on here. Current went up to 80 milliamps. A little bit of scratchy sound when I turn the volume control. Volume wide open, I can hear like a electronic buzzing sound. It probably has to do with that the Bluetooth chip there. Yeah, so you know, already I'm seeing issues with this thing. But you know, you may not listen to it wide open. That sound quiets down when you turn the volume down. Okay, let's put some music into it, see what it sounds like. Okay, let's try a music sample here. I don't hear any hiss or low volume distortions like I did on the other chips. It says here it's supposed to show up on your device as this, BT-WUZHI. It wasn't showing up, so I turned it off and back on, the amplifier that is, and it seems to be working. But yeah, I mean, I should barely be into the first set of batteries. Alkaline batteries, I don't know exactly what their capacity is, maybe like 2,500 milliamp hours, something in that neighborhood. I'd have to look it up. 2,500 divided by 5 milliamp. Why did it do that? I wanted it to stop. 500 hours. There we go. That's the John Audio Tech channel. You ever watch that channel? I don't know about that, guys. Kind of weird. But anyway. Yeah, Bluetooth seems to work just fine. Let's move on to some power tests. Hi, Snickers. Not that boring, are we? Okay, I have the 8 ohm non-inductive loads connected to both channels. So we'll do a power test showing both channels driven just as always. And crank this up. There's clipping. And it's fairly symmetrical. There's a little notch though. It's no big deal. It's gone when it's not clipping. So we'll just take it out of clipping. And at 12 volts, we're getting 7.55 volts RMS on the output. So 7.55 volts RMS divided by 8 ohms is 7.125 watts. And as always, that's pretty much what I would expect. So what I'll do is take some more power measurements and come back with the results at the end of the video. Okay, we're taking a look at the harmonic distortion using the FFT mode on my oscilloscope. I like to use my old Rigel scope. Even though my Siglant can also do this, it's a lot harder to set it up. It's time consuming. I'll have to see if I can store that in a setting or something like that, maybe access it quicker. But anyway, this is the 1 kilohertz fundamental, 4.5 kilohertz pilot signal, and that's at 1% amplitude of this one, and I just put that in there so I can visually compare it to any harmonics. Crank this up, that's clipping. So tune that out. There's a little node of a second order harmonic, but it seems pretty clean otherwise. And as I turn the volume down, it goes away. It's just right before clipping. Get that little node there. Okay, so let's turn the camcorder on so I can actually record the footage this time. So now I'm at 10 kilohertz. There's clipping. Tune that out. I don't have a pilot signal in my 10 kilohertz signal, but it's not real clean. There's several harmonic nodes showing here, even though I adjust the volume control quite a ways from clipping. So clipping again. Turn that down. Yeah, it's not real clean. I've seen much better results from other TPA3116 amplifiers. Okay, we're looking at 20 hertz now. You can already tell it's cleaner. There's clipping. Tune that out. And it cleans up rather nicely. Okay, I'll do a frequency response test using the Field Tech function generator. High quality piece of equipment. Actually warming up to my little Field Tech cheapo arbitrary waveform generator. Arbitrary. Get this thing pointed at the oscilloscope, the silly scope here. Okay, so normally the waveform should be touching this graticule and this one, as it is doing right now. So let me get my Field Tech set up. Every time you push a button, it glitches the waveform. But that's just the way of the Field Tech. So I need to turn this down to a very low frequency. We'll start at like 10. Let's bring this back on the silly scope. And well, it's not very flat. See, there's 20 hertz. We're at 60 hertz. They're about there. So yeah, look at that. It does roll off quite a bit. Yeah, that's 30 hertz. 2/3 of the way there. So not the greatest low end of the frequency response there. And I'll turn this up. It's the wrong way. See, it kind of glitches out as I adjust it. That's because of the function generator. Yeah, it's the Field Tech. This is high quality stuff here. Wow, are you kidding me? It's rolling off already? We're at 3,000 hertz. It's flat at 1 kilohertz and it's starting to roll off. I kind of noticed, I wasn't sure if it was the music I was playing. I'm not that familiar with that song. It seemed like the highs were missing, or not missing, but just kind of weak. Wow, this is awful. Look at that. We're at 1/3 the amplitude. We're at 10 kilohertz. This thing just rolls off. I knew that was going to be a problem because when I was testing the distortion at 10 kilohertz, I noticed the signal was smaller. I had to turn it up. So, yeah. Okay, there's 20 kilohertz. It's just rolled off to very, very small. Wow, terrible frequency response. Okay, I assembled the covers here. Fingerprinty. It goes just like that. It's kind of neat. You can pronounce that if you want. Huangzi Audio Hi-Fi Power Amplifier 50 watt by 2. Well, we know that's not going to happen, especially with that tiny heatsink in there. Here are the power measurements. This column is the supply voltage. It says it runs down to 5, I think, on the instructions, but it says 9 to 24 here. Upside down, all the electrons are going to fall out, like Dave Jones says. But anyhow, it does run down to 5 volts okay. So I was getting just shy of 2 watts, 4 ohm loads, and 1.16 at 8. 9 volts, 4 ohms is getting 6.25, and 3.96 at 8. 12, 11.634, and 7.09 at 8. And so on and so forth with the maximum power. I measured it at 16 volts maximum because the heatsink was getting pretty hot. And we just missed 20 watts. I took my measurements pretty quick. It was, like I say, getting pretty hot at 4 ohm loads. I wouldn't run beyond 12 volts with a 4 ohm load. But with 8 ohm loads, you can probably get away with music. You know, with a continuous sine wave tone, it was getting pretty hot. But with music, it should be okay. Up to 16 volts, where you get about 12.5 watts per channel. 8 ohms. Or at 14, you get about 9.31. So yeah, the power output measurements are pretty much what you would expect at the supply voltage, given the load impedance, and being a bridged amplifier. So nothing surprising or disappointing there. It delivered exactly what I would expect. Noise level, not an issue with hiss or anything, but I was getting that buzzing sound at high volumes. Music, it sounded okay to me. However, when I went back and played some other music I'm familiar with, it does sound like the highs were rolled off, which I did see with the frequency response test. It was pretty awful. It rolled off well before 20 hertz. And really the most miserable part was the high frequency roll off was just, at 4 kilohertz, it was about 66%, or, 2/3 down, and it just got smaller and smaller at higher frequencies. Pretty pathetic. Bluetooth seems to work okay. It's a persistent connection. I don't know if, I'm not a Bluetooth user, so I don't know if that's how it normally works, but every time I turn this on, or cut the power and then turn the power back on to this thing, it would connect up to my tablet. Even though I disconnected it from my tablet cutting power and reapplying, it would force the connection back, so it's persistent. Like I say, I don't know if that's normal Bluetooth behavior because I'm not a Bluetooth user, but kind of annoying. I guess it's not annoying if you use Bluetooth a lot, it'll automatically connect for you. But my final overall recommendation is to avoid this due to its terrible frequency response. Other than that, it's okay. Okay, that'll wrap it up for this one. Thanks for watching.